Okay, so I wanted to do at least one problem here that came out of the homework. And this, this actually could be a practical thing. If, for instance, this was a room and it was oddly shaped like this, and you had to find the area, and you might find the area to figure out how much flooring you needed or something. This was in miles, which, wouldn't be a house, but the idea is the same. What you need to do with this is to break up, there's no formula for this odd shape, but if you break this up into two rectangles, you are good to go. So for instance, the bottom rectangle, its length by width, and these are both marked. So 30 times 6 would be what, 180? Right? And then the top is also a rectangle. And so it's 10 by 12, which is 120. Now, this was all in miles, by the way, but so what you have to do is to get the full area, you would just flat out add the two. So that's looking like 300 to me. And each one of them was miles, as I remembered when we were doing it. So that would be square miles. But if you recall, they put this in for you, and they just expect you to put in the number. Does that make sense? So when you have oddly shaped things, you try to break it down into pieces that you know. I'm going to show you something that actually happened in my kitchen before I moved to Washington. This was, let's see, it was part of a roof. So it was a wall that, I had to put paint on, but that was the shape of it because this was part of the roof. So in order to calculate how much paint I needed, I had to break it down into two shapes that I had formulas for. So this part of the wall was a rectangle. And so I knew the formula for rectangle and I could measure it. This part was the triangle. And then I just added the two, just like I did with this one. You see what I'm saying? Because, sometimes paint's really expensive. And so you want to, at least make an effort to calculate how much you need. And so this was an oddly shaped wall. It wasn't like a regular wall. And so literally, that was the shape. And, we had rafters here. And so this was part of an extension, I guess, that they'd added to the house. So does that make sense? So you would get this area and you'd get this area and you'd add them up. Okay.
That makes perfect sense, but I have a question on the first figure, and this is what messed me up on the homework.
Yes.
You had 10, is it okay for you to put the two rectangles up? Because it's a number I wanted to show you.
Oh, this one?
Yes, thank you. You see, you multiplied the 10 times the 20 and then the 6 times the 30.
Yes.
So I'm clear on that. But when I was doing the homework, like you see how you have another 10 over here?
Yes.
When I wouldn't know what to do with the.
That's what I'm going to do with that 10.
So when I was doing the homework and I saw the other numbers, I should have just been ignoring them and concentrating on the length and the height.
For area, all I need is the length and the width. And this had nothing to do with anything.
Thank you.
Top
Okay,
one
thank you.
was these two numbers. Now, if it was perimeter, you might be interested in it, but it wasn't.
Yeah, it was area.
Area. And so we knew the formula. So that's why, you realize what you're doing and you put that in mind, what the formula is. Right? Okay. So we are down to the last chapter, if you can appreciate that. And I'm assuming that most people will go into beginning algebra next. And so that's what chapter 11 is all about. And so what we will be doing is beginning to solve equations. And so the first topic they have, this is 11.1. And so I wanted to do that one. They want you to remember what this is about. And so if you had to simplify this, if it's possible to add the two numbers in the parentheses, then you would just do that. But guess what? You can't add an X and a 3 because they're not like, we have no idea how much that is. And so these are two separate terms. And so what you do is you multiply each of them by 5. And so this is the distributive property, and they wanted you to remember it if you haven't ever seen it before. Distributive, so you distribute the 5 to each of these. So 5 times X would be 5X. And plus, you distribute to the next number, 5 times 3 is 15. And so when we're working with equations, we like this better than parentheses. This, it's like the X that we're actually solving for is kind of, you know, caught inside the parentheses, and we want to let it out. So we distribute that. And so if that was the case, now this is not an equation. This is just a part of simplifying. But let's see what else we can do. All right. So they start out with some expressions. They want you to evaluate an expression. So it's really just to find the value. So these are just necessary skills in order to do this equation solving. So if you had something like this is an expression, an algebraic expression, and somebody said, okay, I'm going to tell you what X equals. Then can you do something with this knowing what X is? And the answer is, of course you can. And so what we're going to do is substitute. So every time I see that, I'll put in 4. And so when you substitute, or they might use the word evaluate, they might say find the value, but they've told you what the missing letter is. When you put in the number, put parentheses around it and insert it into the problem. And then that's +2. This reminds you that these two are multiplied. And once we start to work with negative numbers, it's going to be a lifesaver. So it's something that we want to do from the beginning. If you're going to put a number in for a letter, put parentheses around the number as a habit. At this point in time, the first line doesn't matter. We're only interested in this line. And so now order of operation kicks in. Remember order of operation? Parentheses, exponents, multiply, divide, and lastly, add and subtract. And so we learned order of operation way back, but in this particular case, the multiplication is done long before you add. So 4 times 5 is 20. Now we can add the 2. And so this is 22. So we wanted to just, you've probably done a little bit of this already, but we definitely wanted to remind you of these issues. So I've got another one. What if I have 3x minus 9? And oh, what if they told you the crazy x was a fraction? Do not panic yet. because we don't know if that's going to be a problem for us. So here's what I have. I've got to insert 2/3 in for this spot. So this would be 3 parentheses 2/3 subtract 9. So our skills with fractions kick in. Notice how I wrote the 3 high, and if I was smart, I'd put it over 1 so that I can clearly see this number and this number will reduce. So 3 and 3 are the same, so I can reduce them out. And so I'm really just simplifying this part here. And so it's 1 times 2 is 2. 2 over 1 is just plain ordinary 2. Is that okay? 1 times 2 is 2. 2 over 1 is 2. That's the simplest version. Then I have to subtract 9. This goes back to chapter 10, which we did earlier in the course. If you had 2 and you subtracted 9 from it, you're going to end up in the negative. The question is where? And so you're going to be below 0. And if this is positive, which it is, and this is -9 or subtracting 9, what you do is you subtract the 2 numbers, and it was really the absolute value. So the answer is 7, the number part, but is it -7 or +7? When you take away more than what you had. This is like banking. You had
Negative.
$2, it's negative. You had $2 and you take away 9. You're in the negative side, let's face it. But what you do is you subtract the 9 and the 2 to get the number. And this is when the 2 numbers, one is positive, one is negative. It's -7. So I wanted you to be aware of that. I want to do one more before we move on. -4y plus 9. And I want y to be -1. So we're going to keep reminding you of the positive and negative numbers. So when I substitute -1 for y into this expression, I would go -4 parentheses -1, so that came down, plus 9. Now I have a habit. These go together because they're multiplied. Then the plus 9 is a separate term. And so this goes together. So I want you to see a -4 multiplied to a -1. And a negative times a negative, do you remember? Do you remember?
Positive.
It's positive.
Positive. And somewhere I kept that page, but I can't locate it right now. But it's +4. So this mess is now +4 plus 9. So ignore the messiness, and we're down to this line, and the answer, of course, is 13. Okay, so we improved it greatly and got it down to a single number, and that's where we're at. Okay. All right. Now, let's see, what else can we do? So they do quite a bit of problems like that where you substitute in. Now, okay, what if they just made it a little bit harder? Okay. And now x is 3. All right. Now, there are 1, 2, 3 terms. And so we're looking for 3 numbers, and then we'll put them together if we can. And so one thing we could do is multiply 3 times 3. Notice the parentheses. I won't stop doing that. 5 parentheses 3 plus 4. Okay? So you want to do the multiplication first. So 3 times 3 is 9. 5 times 3 is 15. And then the plus 4. These problems, the terms are going to be separated either by an add or a subtract sign. And so this is 1, this is 2, this is 3. So we could actually finish this. 9 and 15 is what, 24? And that's 4, and that's 28. This will eventually lead us to something that's going to be necessary. And I'm going to go back to the original problem. And maybe this will be easier. These first 2 terms are considered like, they're alike terms because they're both x terms. And so they can go together. So the 3x and the 5x could go together. How many x would that be?
Oh, 8x?
It would be 8. Now the plus 4 doesn't belong. It's not part of the x's. And so you just say plus 4. So what we would do is 3x and 5x. And so you can think of it like anything you want, but x's add to x's and y's add to y's. And so if you're going to add, you need to have like things. Now, the reason I could add these because they were all alike. They were all plain, ordinary numbers. And so plain, ordinary numbers can be added because they're alike. This is a rule that, honest to goodness, I've never seen it in a textbook, but here, they should have said this on day 1 from your math class. To add or subtract, you must have like things. I'm just going to use that word. Have I written this before? This means that I could add a plain number to a plain number. I could add 3x to 5x and get 8x. And all that fraction stuff that we did also applies to this rule. If I had 1/5 and 2/5, these are like the common denominator makes it fit this rule, and now we're allowed to add it. And so 1 and 2 make 3. This was so fundamental that it seemed like people forgot to mention it. But once you go into algebra, you have to accept this, that you add an x to an x. And so we already had to do this. The other thing, it had to do with fractions too. I can't add 14 and 0.5. I have to line them up. So I'm adding a 10th to a 10th, a whole number to a whole number, and so on. That's the same exact rule, that if you want to do this adding and subtracting, that's what you need. And so that's why, and so this is just so ridiculously fundamental. You may have heard the phrase, you can't add apples to oranges. They were trying to talk about that. The reason I added 3x and 5x is because now it might be a little bit simpler to do the problem. The simpler version of anything is always better. So 3, remember x was 3, so 8 times 3, that would be 24, and 4, That would be your 28. Can you see that that was a little bit simpler? We love simpler, because the messier it is, the more mistakes we make. And so we're always trying to consolidate things. We don't want 9 and 15 and 4. No, no, no. We want 28. See what I'm saying? We want the simple version. We don't want 100 divided by 300. We want 1/3. Simple, nice. Okay, is that all right with you? So,
Yes.
yes. So, they did a couple of problems. This will be sort of review. We want the perimeter of this, except now I'm going to be fancy. I'm going to call this 2x minus 1, and I'm going to call this 3x plus 2. And I want the perimeter, and the answer will have x's in it. So if this top one is 3x plus 2, the bottom one has to be, like it or not, same. Acceptable? And the same goes for this one. If this is 2x minus 1, that's the same. So the perimeter is basically going around the edges and adding them up. Now, one thing you could do is you need 2 of these. So this will practice our distributive property. We need 2 of these, and we also need 2 of these. So I need 2, and I have to distribute it to both because I need to double the whole thing. So this would be 2 times 3x. That would be 6x. And plus 2 times 2 is 4. Everybody good with that? Somebody taught me to do these lines, and I can't stop it. So I've been doing it for a long, long time. But I think it helps to remind you that the 2 goes to both of them. This one here, 2 times 2x would be 4x. And now here I have 2 times -1. It's basically minus 2. So it ends up being subtract. So 2 of them added up to 6x plus 4. The other 2 sides added to this. If I want the total perimeter, I would add x's to x's and plain numbers to plain numbers. So 6x and 4x total 10x. And plus 4 and minus 2 are separate terms. They're not like that. So you would just say plus 2. And so you have to have a sign to say you went to the next type of number. So it's, now if you had gone around the edge and added them all up, you would have come up with the exact same answer, 10x plus 2. Okay, so that's practicing our distributive property. And let's see, how's our time? Okay. They have a few of these funny problems in this section, so I'm just going to mention it. This is a right angle, and a right angle is 90 degrees. These are perpendicular. That's another way to say it. So if you had a line going through here and you said, oh, okay, well, this is 30 degrees. And you knew the whole thing was 90. Can you tell me how much this is? Anybody want to guess?
60.
It's got to be 60. Because the 2 together made up the angle, and one was 30 and one was 60 degrees. And so together they made 90. So let's say you had this And they said, how many degrees is that?
90.
It's 90. There's no problem. This one here. So let's say this one is 10 degrees. How much is this one?
80.
80. 80 it is. Okay, so it's not a big deal, but for some reason they threw this in on this section. And so I believe you can do them. There's another kind of angle. And it's really amounts to two 90-degree angles. So you had a 90-degree angle here and a 90-degree angle here. This is called a straight angle. And it's 180 degrees. Because it's made up, this went straight across the bottom line, and so it's 90 on the left and 90 on the right. So if you had that kind of an angle, and this one was 50 degrees,
It'd be 130.
it's 130. So this is not a big deal. But they did throw this in, and so as long as you realize that one of them, these are 90 degrees, and the straight angles are 180 because they're really two 90s, then you could do all these problems. So I'm not gonna fuss too much about that. So the truth of the matter is, if somebody said, we're going to teach you how to solve equations, they usually start with the following. And so I want to run through some of the steps that you might see. Previously, they probably just said, can you figure it out what X has to be? Well, a lot of problems are not that easy. And so we have to establish a really good way to get the answer without a lot of sweat. And so this is an equation. What makes an equation? You have some expression on the left, something on the right, and equals are in the middle. That's an equation. Left, right, and equals. The whole job, and we've done this already, is to find out what X is, because I know about the rest of it. So these are the steps we're going to use, and as it gets more complicated, we'll continue to use this type of thinking. You find the side, left or right, that has the letter. You then find what is next to it. And what's next to it in this particular example is a +3. Nobody in this world cares about X + 3. What they care about is X. How much is the missing number? And so what we have to do is really get rid of the +3. And so when you see it's adding, what you want to do is subtract. And I like to put it below. Sometimes they put it to the side, but I like it below. But nevertheless, once I do it to the left side, I am forced to do it to the right side. So don't be hoping you'll remember to do it at the same step. I took 3 away from this, I'm going to take 3 away from that. And then they still should be equal. The plus and the -3, if you add 3 and subtract 3, you get 0. So you now have X + 0. Over here, you have 7 take away 3 is 4. Now, most times I don't bother with this step because I know that plus and -3 are 0. So I just go to the last step. The only thing left here is X. The answer is 4. So that's what I'm going to do. I'm going to do a lot more examples, but I want you to see that's what I did. So for instance, if you had an equation like this, You find the side with the X. You find that if anything is next to it or near it, you're going to deal with it. And so what I see is subtracting 5. I don't want subtracting 5. I want that to go away. And so to make things go away, you do the opposite mathematical thing. So the opposite of subtracting is adding. And so I'm going to put that right below it. But the minute I do that to the left side, I come over here and actually say +5 to the other side. See how the two sides? People are actually taught put dotted lines here so you can see the two sides. You don't have to put dotted lines. But subtracting and adding 5 go to 0. And so what is left is the X equals. And the answer appears over here, and this is 17. If you get it right, then it will check. And I'm going back to the original problem, which is this. X subtract 5 is 12. If I substitute 17 in for X right here, 17, take away 5 is 12. If it checks out, that means this one is correct. And so as things get harder, you know, this was a guess. You could have guessed that it was 17, take away 5 is 12. You could have guessed it. But what we're interested in is a technique for things when things get harder. You have already learned to do this. That was the first thing they taught you. If you have, and this, I don't see anything there, so I'm going to put a little dot to remind me it's multiply. I want X alone. I want the 3 gone. I'm going to get rid of it. 3 is multiplied to X, so I'm going to divide by 3, divide by 3. Same. This doesn't go to 0. 3 divided by 3 is 1. And so this becomes 1 times X. Over here, this is 21 divided by 3 is 7. But again, I typically don't write that step, although that's a correct step. I just say, that's 1X. I'm going to just go to it. X is 7. Why is this answer slightly better than that answer? It's because they love the simplest version of every single answer. And if this is simpler than that. It's almost as if they were trying to save the pen. Or if I was on a chalkboard, save the chalk. Don't write anything extra. So this sort of complies with things that you know. When you had answers like 3/1, typically you'd change it to 3. You know what I'm saying? Simple. They love simple. 1X means 1X, but is typically written just plain X is 7. How do you like that? And I'm going to follow this sequence. If I had X divided by 5 equals 10. So I've shown you add, subtract, multiply, and divide. This is divide. This is X divided by 5. If it's division that's going on here with a letter, the opposite of division is multiplication. Does that make sense? So we're undoing the thing that's there to get it down to plain ordinary X or whatever your letter happens to be. The minute I multiply this side by 5, I will multiply this side by 5. Now this 5, I wrote it high because it's really 5/1. And I put it 5/1 to keep my numerator and denominator separate. But can you see that the 5s are going to hit the dust? They're gone, right? So it's 1X, which I'm going to just say plain ordinary X. But the answer is appearing over here. It's 50. So that's our answer. If you go back to the original problem, X over 5 equals 10. And you put 50 in place of X. So that's 50 over 5 Does that equal 10? I think so. So this is the check. And once in a while you have this bad feeling, I think I made a mistake. Oh no, oh no. So you take it and you put the answer in to the original X and see if it's any good. And chances are you were okay.
Isn't the cross-checking just like what you do at proportions, where when you figure out what X is, you just put the
It's
number?
the same thing,
finish out the
yes.
problem?
And you're putting, I always take a joke, it's like, pretend you cared. Because if you just turn in your answer and say, here's my silly answer, you take it. But let's say you really, you wanted to get the points, or it was money, you wanted to get your money back or something, you cared, then you check to see is it any good or not. And I think it's a joke because you won't always care about every math problem. But I want you to pretend that you do. And I'm trying to be sarcastic, obviously.
I just have a small question. I noticed for that problem, you put the 5/1 times the x/5. Even though the x/5 is division, in this case, we wouldn't switch the reciprocal.
No, because it's multiply. And remember, with multiply, there's no switching.
Oh, so, okay, so we're already multiple. Okay, thank you.
So
So it stays as is.
you're right, but it wasn't, that part was division because it was a fraction. But
Okay,
to fix it, we multiplied, so there was no need, multiplying does not require making a reciprocal.
thank you. Okay.
Good job. So it's starting to pull together. So I'm just gonna pull out some problems. So occasionally you're going to see those negative numbers and we're going to keep having to remind ourselves what were the rules. But in this problem, this is an addition problem, and it's the letter A is the missing number, and it has 3 added to it. If it's an add 3, we've got to undo it by subtracting 3. And I like to write it, and I subtract 3 over here. And I put the minus sign so I don't forget to subtract. The plus and minus 3 are 0. And so that's A plus 0 is A. But the real answer is over here. And if I have -1 and another -3, how much do I have? So this is going to bring this all back. Answer?
-4.
-4 it is. Okay. Let me find us another one. Oh, look at this one. I don't know if I want to do that yet. Well, maybe I'll do it. I'm going to do this one. This is slightly different. The left side needed to be simplified. And so whenever you see a slight mess, the answer is clean it up. And so how much is 2 subtract 6?
-4.
Correct. So the minute we see a mess, we clean it up. Now the letter, so we did that. So cleaning up is what we do first. The letter is over here. It has a -1 to it. What do I do to get rid of it?
Add 1 to both sides.
Add 1, and I'm going to say +1. I'm going to put that plus sign. So because sometimes you do it right over here and you don't do it right over here. And so put the sign. So the plus and the -1 go, and we're left with letter A, which is what we want. We have to put these two together. So -4 plus 1, how much?
-3.
-3 it is. Okay. And whether they write it -3 is A or A is -3, that's the same thing. Typically, they would put the letter here and the number here, but these are both correct, and so it just do whatever the homework asks you to do. Let me see if I can find something different. I have a problem that looks like this, and this was the one I saw first. So we're moving forward. And there's 1, 2, 3 terms on the left, and just on the right, all I've got is the number 4. So I'm more interested in this side. Remember the commutative and the associative property where you'd move things around to suit you? Where you'd switch the order and stuff? You don't have to write this, but I'm going to write it so that you can see what I'm thinking. I'm going to bring the minus 4a to the middle. So I want you to see what I'm thinking. So what I did was I switched the order. Notice the minus comes with it. Now I didn't have to write this, but I want you to see the reason I put this together is because these are like terms. That's 5a subtract 4a. Okay? And if you want to make it concrete, if you're thinking it's 5 apples, take away 4 apples. How many are left?
A,
1 apple. And so 1 apple is really just A. Right? 5 take away 4 is 1. And chances are we would write it as just A. I still have the plus 6 there. It didn't go away yet. And now my 4. So I put the 2 together. Now, did I have to rewrite this to do that? No, I didn't. I could have done it in my head. The 5a, and notice the sign goes with this term here, subtract 4a. But I put it together because that's what my brain was thinking. I wrote it out, but I could have just said, oh, those 2 together, 5 minus 4 is 1. And I still have the plus 6, but maybe this was not a bad step while we're learning. This is add 6. Here's my letter. I need to get rid of add 6. I do opposite every time. Opposite of adding, subtract, subtract. The plus and the minus 6 hit the dust, it's 0. I'm left with A. And I have to compile this. I have 4, I take away 6. I'm in the negative zone here. How much?
-2.
Yes. How's that? So what we're starting to see is if you have a mess, and this original problem was a mess because there was a simpler version to it. So when you see the mess, that's always step 1. Clean up each side. This was clean. This side was a mess. And so I put this together and got A plus 6. Now that it's as good as I can get it for the moment, I find the letter. I see it's adding 6. I subtract 6 both sides. And then finally, the plus and the minus 6 make 0. So that's gone. How's that? I'll try another one. 10
Yeah.
subtract 6 equals 8x subtract 7x plus 6. I have a mess on both sides. And this is my definition. There's no such thing as a mess in algebra, but I'm going to call it a mess. 10 take away 6. 4. Okay, that side's good to go. This side has, I want you to see, it's 1, 2, 3 terms. The terms are separated by either a subtract sign or an add sign. And so there's 3 of them. The 2 here are alike. So I'm going to put them together. I don't like messy. So 8x take away 7x is what?
Just X.
1x or x. And the plus 6, I can't throw things away. I have to. Because I'm stating that these two sides are equal. And so I have to be fair about it. I subtracted correctly 4. I put these together and called it x. I didn't throw away the 6. It's still equal. It was equal to begin with. It's still equal. That's the whole idea of an equation, equal. Now the x is over here. I have to ditch this. So instead of adding 6, I'm going to go subtract 6, both sides. Cancel, cancel. That is 0. This is x. And this is the same, I think it was the same as that problem, wasn't it? 4 take away 6 is -2. Right? Or very close, same answer. What do you say? Anybody have anything to say?
I'm starting to remember it from my junior high days.
Okay, well, I'm going
Yeah.
to, oh. Step 1 in solving an equation, which is what we have, and finding the value of x, is to simplify. That's another way to say clean up the mess. Parentheses need to be fixed. And so we're going to do just the way we were taught. So this, to get rid of the parentheses. So it's 2 times x, 2x, plus 2 times 3 is 6. Everybody happy with that? 2 times x plus 2 times 6. But then I had a minus x and equals 4. That's okay. I have 1, 2, 3 terms. 2 of them are alike. And they need to be combined. So if you want to rewrite it, or just think it out, it doesn't matter to me as long as you're able to do it correctly. If you wrote it out, it would be 2x. The sign would come with this part of it. And then plus 6 equals 4. So if you brought this second and this third, then these two would go together, and 2x take away an x, which we all know is 1x, is just 1x. And then 1x and 6 is 4. Now what? One more step and life is good.
Do
Opposite,
we subtract both sides by
subtract. And plus 6 minus 6 is 0. And so we're down to just plain x, which is what we actually wanted. The answer, I'll get a lot of -2s. There you are. How is that? I want to do a little weird one. -2 x minus 5 plus 3x, oh my, is 4 minus 9. Okay. I'd say the both sides need some work. So you can do either side first, it doesn't matter, but we've got to, this one is a little bit easier than this side, but it doesn't matter where you don't move on until both sides are good to go. And so this one here, the -2 needs to be distributed to the x and the -5. And so I'm going to do that. Now, I want you to be really careful here. So -2 times x is -2x. But the simplest way to do this next piece is to pick up the sign -2 times -5. So a negative times a negative is a positive, and 2 times 5 is 10. There's other ways to do it, which takes a lot more steps. But I think this in the end is the best. -2 times x, that was okay. But -2 times -5, treat it as -5. 2 minuses make it plus. I'm then going to add my 3x. And while I'm on this, I'm going to finish this and then I'll go over there and do that. I've got 1, 2, 3 terms. I instinctively put a little space between them so I can see them. Sometimes when they type it into a program, they don't have the spaces, but I just instinctively want to see them as 3 pieces, 3 terms. This one and this one are alike. They're both x terms. And so the 3x minus the 2x can go together. And then we still have the plus 10, which I'm not going to throw away. And 3x take away 2x is 1x, and 1x plus 10. Okay, so you could have done this step in your head, but I brought it over so that this is what I'm thinking. Whether you need to write it or not is up to you. Over here, you had 4 to the positive, but you took 9 away, so now you're in the negative again. How much negative? Anybody know?
-5.
It's -5. So you subtract the 2, but you take the sign of the larger one, and this larger one is negative, so that's what you do. Now we finish this. This is the finished part. Get rid of plus 10. I do the opposite. And I subtract 10 on both sides. When I write it down, I can then see if there's something goes wrong, I can see that what I did. And so that's 0. I'm left with plain, ordinary, good old x. And now I have -5 and another -10. So I'm still negative. How much?
15.
Negative what?
15.
Correct. Is that okay with you? Okay. Oh, there's one more weird one, then I'm gonna get off and go to another something else. Oh, this bothers people. What bothers them is the minus out in the front of the parentheses. And so this is one way to see it, is you're taking the opposite of every one of things in the parentheses. You could also see it as multiplying by -1. If that makes it clearer what's happening, then drop a 1. Even notice I even left a space here just in case. I'm gonna put it in an orange. If that helps. But when we do the opposite of x, it's -1x. And we now do the opposite of -7. The
Awesome.
minus times a minus is a plus. Can you see where this is going to get? This is where you're going to get snarled. And then it's plus 2x minus 8 equals 4. On this side, this was the last one on this page that I just did. 1, 2, 3. I have 4 terms on the left side of the equal, and I have to put them together. These 2 are alike, and these 2 are alike, aren't they? So in my mind, whether I write it or not, I'm thinking I've got 2x minus 1x. I've got plus 7 and minus 8. So notice when you move things around, the sign goes with them. So 2x take away 1x is x. 7 take away 8. Negative 1. Or subtract 1 equals 4. One more step. Yeah. Exactly right. So that's x equals 5. And after all that work, I sometimes circle it so they don't lose it.
Okay, the first parenthesis, that's why I was lost.
Yes,
So when it's written like this, we're not multiplying the -1 times the +7. We're just changing the signs in the parenthesis if it's outside of the parenthesis.
I'm going to write it again.
Okay,
In just that part, because that's the
okay,
confusing part. There's all kinds of ways to interpret this symbol. One way is to say, I'm going to do the opposite. Now, that works. And so if you do the opposite of x would be -x.
um,
And if you do the opposite of -7, and
It
I'm
would be-
picking up the sign at the
Yeah.
moment, that would be +7. That's one way to see it. Another way to see it is multiplying by -1. It will accomplish the
oh,
same thing,
yeah, it's still a positive,
Right.
okay,
negative x.
yeah.
And negative times a negative is positive. So using this to interpret as the opposite of these two, so that what was plus becomes minus, what was minus becomes plus, that's doing opposites. Or multiplying by -1 accomplishes the exact same thing. So
Right.
it's whatever floats your boat.
Okay,
We're in Maine, we have
so
to.
much, okay.
Well, Seattle's pretty good about boats. Maine was like Seattle in the fact that there was a lot of islands, there was a lot of water, you know. Got it? So this is tricky, and I understand it's tricky. There's no doubt in my mind, it's tricky. I'm gonna do just a touch of this because we have a few more minutes. But the multiplication property, we've done this so many times. It became part when we did, I think it was proportions, we had to learn this. So if this was the little equation we had and it was, the letter was multiplied by a number, one simple thing to do is to divide. So 5/5 is 1, that's 1x is 4. But I think most people got that because we had to do it a number of times. And so I think the minute you see this, 7x is 14, you're going to say divide by 7, and you're going to be a happy person. There is one thing in this section that is a little bit different, and I want to show it to you. If you had this, when we had a whole number like 7, dividing by 7 was no problem. But when we had a fraction in front of it, if I started dividing by a fraction and divide this by a fraction, I've taken a fairly good looking problem and made it look even worse. Will everybody agree that doesn't look as good as? And so maybe there's another way, and I wanted to show that other way. So if you had 1/2 times x equals 3, and I want to get rid of 1/2, don't I? I'd love to get rid of 1/2. One thing that can be done to get rid of 1/2 is to multiply by the reciprocal. I want you to see that that accomplishes it without making a mess out of this problem. 1/2 times 2/1, the 2's would cancel. And you'd be left with 1x, which is x. And over here, I have 3 times 2/1. That's really 6. So that when a fraction was involved in this, I think that made our lives simpler. So let me make another problem so you can see it. 2/3 x equals 12. Instead of dividing both sides by 2/3, which is messy, we could survive it. We could, but I think you might consider, and so I just wanted you to have time. This section I don't think is due Wednesday. This is, but I wanted to bring this up. If you saw the 2/3 and you said, and you multiplied by 3/2, look at how beautiful that is. The 3's hit the dust, the 2's hit the dust, and you're left with plain ordinary good x. And the answer appears over here. I'm going to put the 12/1. And I'm going to reduce the 12 and the 2. And, you know, some of you cancel. 6 times 3 is 18. And that would be your answer, 18/1. Otherwise, you would say 12. The other approach would be 12 is 2 times 6. And you would break down the 12 and then you would hit out the 2's. And that would give you the same answer. 6 times 3 is the 18. But one way or the other, I wanted to show you that it's sort of like an odd problem, but it's actually mathematically easier to use the reciprocal on that. And I probably would, knowing the trouble the other way would do. Okay. So what do you say? Have you had this before? I guess if you had any algebra in high school, you would have had this before.
Yeah, but I was lost the whole time.
Well, are you less lost?
Oh, yeah, definitely, definitely.
So let's see when you had an equation, if it said add 5, you subtracted 5. Well, if it was subtract, you added. If it was multiply, you divided, except for this crazy one. And if it was divide, you multiply. You just do opposites. So far, step 1 is to simplify each side. So that's where I would say, if you see the mess, clean it up. That would include distribute parentheses. I'm just going to write like that. So an example of simplifying, when we had 4 subtract 9 equals 5 times x plus 3. The simplifying would be putting this together into one number, not 2. So 4 take away 9 is -5. And if this side looked like that, then getting rid of the parentheses, we would distribute. This would be 5x plus 15. So I'm not going to finish this because this problem is one step further down the road. But I wanted you to see, if you see that, do that. If you see that, do that. And there's one more thing. If you have 3x plus 5 minus 2x is 6, you count your terms, and I have 3 of them, and 2 of them are alike, you combine like terms. So you, the 3x and the minus 2x are combined into 1x. And so that's part, all of these type of problems fit the category of simplifying each side. Okay? And so we do that first. We don't want to start with a heck of a mess and try to survive. We want to clean it up so that it's down to the as simple as possible before we start doing things like adding 5, subtracting 5, doing this or that. We want it simple. And the more terms you have and the messier it is, the more chance there is of a mistake. So we clean it up at the beginning. Any question about that? Yeah. So that's what I want you to do. I'm going to stop the recording. I think. Let's stop it.